Hi, this is Martin Lohr, CEO and co-founder of Sixonia Tech, and in this short video, I will show you how our graphenes can be used in energy storage applications. So, graphene is a material that combines a lot of wonderful properties inside a single material, but as a new material it also faces quite some challenges. Typically, new materials that are fresh to the market, not very mature technologies, have problems with batch-to-batch consistency. In case of graphene, a very specific problem is that up to now it was not really possible to combine high processability and high quality in a single material, which also leads to the problem that you have a material that is probably not adding as much value to your application as you would have hoped for. So this is the mission that we basically have to overcome this discrepancy between processability and quality. And basically what we are doing is we are using electrochemical process. There is another video where I explain a little bit more in detail what are the differences, but I think this table here also shows nicely how we are combining with our technology the best of both worlds of the two other large-scale production methods, which are basically graphene oxide, reduced graphene oxide, and liquid phase exfoliated graphene. So let's take the quality aspect. Obviously we are not having a material that is so pure and so pristine as a material that is exfoliated by simple mechanical methods. On the other hand, our material doesn't have so many defects like a material graphene oxide that is oxidized to the point where it's, for example, not conductive anymore. But our material, due to the functional groups, really is adding a lot of processability, but still keeping the conductivity and in a way that it's like really outperforming most of the other materials in several aspects. So that's basically also the reason why it is interesting to be used in energy storage applications. So if you look at this like general spec sheet of our material, basically we can achieve quite large lateral sizes while still having a very thin and flexible materials, typically up to maximum 10 layers in dispersion in thickness. So the electrochemical process as well allows us to functionalize this material tailorably. So we can add different functional agents that will allow the material to, for example, disperse in different kind of solvents or metric systems. Or, as I will tell you a little bit later, also add additional functionality in this energy storage application itself. We are currently in the process of building our first pilot line with this capacity of 1 kilogram per day. This will be finished this year, and if we even think further into the future when we're talking about really large scale production. Also, prices way below 100 euros per liter are realistic for this technology. So if you look at other graphene materials that are available on the market, what you typically see is something like this. So you have rather large flakes, but they're not very flexible, so they're not really looking like what you would expect from a graphene material. They're rather stiff platelets, and actually this is what is called graphite nanoplatelets, and maybe they shouldn't be sold as graphenes because they don't really have graphene-like properties anymore, but anyway, this is how it is. Many people for marketing reasons probably still sell these materials as graphenes, and they are available rather like at low cost and high qualities, but they will not really give the properties that you would expect from a real graphene material, but they might still be interesting as a simple graphite replacement, for example. So if you look in comparison to that at our materials, so Sixonia E-Graphenes that are really few layer graphenes, and you can see in the SEM image here on the side very nicely that the flake size is really rather large in the micron range, whereas if you deposit this material, for example, via spray coating or vacuum filtration, you can really see that these materials, due to their few layer nature, are conforming very nicely to the surface and are packing very densely. So in fact, in the center image in this vacuum filtrated film, you cannot really distinguish the individual flakes anymore for that reason. And actually, these materials achieve densities up to 80% if you're vacuum filtrating them like this compared to pristine graphite. So the advantage of this kind of material is really that as an additive in a battery electrode, you need much less of these materials compared to your standard conductive additives like conductive carbon or carbon black particles. And at the same time, this allows you to increase basically the amount of active material in the same volume of battery or in the same weight of battery. And what we've also seen, unfortunately, I cannot really share the specific results here, but what we have seen in the collaborations with our customers is that we can also increase the high power, like the rate capacity, a lot. So it's like you can store much more energy much faster in using the same battery chemistry as before. So if you're interested in any of these applications, I'm looking forward to talk to you and talk about some more details in that direction. Apart from the batteries, also supercapacitors obviously are interesting application field for these materials, as they can also be used as an additive. So simply using our graphenes as a conductive material, for example, in combination with an activated carbon, this might have a very high surface area but rather low electrical conductivity. The fusion of these two materials can really lead to very promising performance, and we have seen that also in some collaborations. But also very excitingly, the ability of our process to functionalize the graphene also gives us the opportunity to basically functionalize the graphene itself with pseudocapacitively active groups. So you can add basically additional capacity to your supercapacitors by using different kinds of organic or inorganic functional groups. And we just recently published a paper in collaboration with the university on that. So if you're interested in that, please just get in touch and I can share that with you. So yeah, basically that's it. I thank you for watching, and I'm looking forward to talk to you if you're interested in how we can unlock the potential of graphene for your energy storage application. Thank you very much.